pulse is getting lower.
The cancer is getting worse.
Bring me the acetylene.
I think I have the solution for it. Look, here I have nanorobots. With the help of my father, we inject them, alright? So, but what? The technology doesn't exist. Even if we have, it will take them us to do. Just stay here on the nanorobots. And here in these papers, it's all explained. Look, alright? You should read this and use it. You can save my father, alright? Go! Ahead. Everything will be fine. Don't worry.
What just happened, Father? What do you tell the doctors? What they're going to do now?
Well, do you know what is your grandfather's illness?
Yes, he has cancer, but what do you tell the doctors?
You know what I work?
Yes, you're a scientist. You work on little things, I think. I'm not sure.
Well, I guess you have kind of an idea. But while the doctors work, let's walk through the park. Let me really explain you my work, that which you call controlling little things. Let me explain you about the art of nanotechnology. Let me explain you the basic idea so that you can understand the nanotechnology and the huge potential it has. Let's see.
Imagine some kids playing with some building game pieces. They would have a lot of pieces with different shapes, sizes, and colors. With all these pieces, they would have countless possibilities of what to create, with their imagination as their only bond. They could create a car, they could create a spaceship, and as well, they could create a building. So, if you compare with nanotechnology, you have diverse pieces, each one with a different potential, which you can explore and use to achieve different goals. Which are the pieces in this case? Well, nanotechnology, as it is called, it works with particles and materials at nanometric scale. But this have probably confused you, and you don't know what is nanometric scale. So here it is an example so that you understand the size of nanometric scale. Imagine a huge soccer stadium. It has a field in the center, thousands of chairs, and a huge structure. Well, if the stadium would be equivalent to a cubic meter, then a nanoparticle would be equivalent to just a little bottle of water in the middle of the stadium. And just imagine incredibly small that a nanoparticle can be. Being exact, a nanometer is 1 billionth of a whole meter, being very small, invisible to our eyes, and even invisible to the traditional microscopes that you use in schools. We're talking about materials even smaller than cells. In order to listen to the voice of another expert, let's travel to the Swiss Federal Institute of Technology in Lausanne, one of the public leading universities on the management of nanomaterials in the world. Here, we would find the advice of two very good chemists.
Is nano-war.
Yes.
So,
Okay.
for example, if you take this 1 meter, this it will be 1 centimeter. 10 of these, if I divide this by 10, it will be 1 millimeter.
Yes.
If I divide the 1 millimeter by 1000, it will be micrometer. If you also divide this by 1000, you will find the famous nanometer.
But now, we have just introduced ourselves on the size of nanoscale.
not talking about the actual nanotechnology. So, what is nanotechnology? Nanotechnology is the manipulation of nanometric scale particles, objects, materials, and even molecules, which is used across all scientific fields such as chemistry, biology, physics, material science, and engineering. Just notice that everything in the world is made up of atoms: the house that we live in, our food, the clothes that we wear, and even our bodies. So imagine what are we able to do if we can control these small materials. Nowadays, there are plenty of applications from all parts of the world. There are different scientists working on it, all with the objective of solving different problems. Scientists are using this technology for achieving many objectives related to medicine, for example.
mm, manera hoy en día de introducir materiales al interior del cuerpo humano por vía sanguínea sean programados para que liberen ciertas sustancias al interior del cuerpo humano y ataquen de manera particularmente selectiva, por ejemplo, las células tumorosas, los tumores cancerígenos, y frenen o inclusive paren un
Wait,
cáncer.
Daddy, what you're planning to do to Grandpa?
Well, maybe. But let me finish my explanation.
It's amazing what you can do, Dad.
Let me finish. Because with nanotechnology, we would be able in the future to build an elevator just right to the outer space.
What?
Well, yes.
The idea is that in a future, when we understand better how the laws at a nanometric scale works, we're going to be able to build a lift that will go from our planet just right to the outer space. How could be this possible? Well, the idea is to build it with super strong but small nanotubes made up of many carbon atoms that would be assembled all together, resistant for being that long in the middle of the space. But apart from it, nanotechnology has application also in computation technology, architecture, clean energy, and all kinds of problems that you can imagine. To be able to achieve all these huge innovations, scientists should take in consideration different characteristics.
The nanoparticle for a possible answer according to the shape, according to the charge, according to the potential that the nanoparticle have.
This means, like in the example of the Lego pieces, that each object has its characteristics, and it should be used for a certain job. Nanotechnology workers should take in consideration these characteristics of the different particles that they would use, because each material has a specific characteristic. But before we continue deepening in this technology and the huge amount of possibilities it brings, let's see how the idea of controlling these individual atoms started. It was in 1959 when the future physics Nobel Prize Richard Feynman gave a talk in a scientific conference saying that controlling individual atoms and molecules would be possible in the future. And although it wasn't after more than a decade, the first investigations relating the control of nanometric particles started to be developed. But how to achieve to control so tiny materials, knowing that they couldn't even see them? Then started with the idea that seeing deeper would be possible. They left the microwave and they started to think in the nano.
This was the question in the 80s. They were asking themselves, yeah, but we said that micrometer is not the unit, is not the most small one. It means that we can divide it to more small, and how we can see it.
So, the scientists were intelligent and they invented a brilliant method. With light, they would excite a nanoparticle to emit a specific signal. This signal will be an emitted electron that would be emitted from here to the outer level. This movement will give us the signal and we can process it as a picture.
This is how we can see 1000 of micrometer. It means 1 nanometer. Okay? Physically, we cannot see it. I mean, we cannot say there is one nanometer. No.
Nanoparticles which scientists uses for their inventions are very tiny, just some nanometers big, being many of them in just one sample. So, with the first principle of how to see nanoparticles, scientists proceed to create equipment for observing and manipulating them. Then, they created the electronic microscope, which they can use to control individual atoms. But which is the objective of using these materials? Knowing the challenges that it can be manipulating so tiny objects, why did scientists had make extra work just for managing nanometric structures? Well, it has one specific reason.
Porque si los materiales no están en forma nanométrica, su comportamiento, sus propiedades químicas, fotoquímicas, mecánica, son completamente diferentes, no son las mismas. Las propiedades de la materia nanométrica es completamente diferente de la materia macrométrica o milimétrica, etc.
For example, if you drop an apple in any part of the world in our normal macro scale, it would surely fall attracted by the gravitational force of the Earth. But if you reduce yourself to the nanometric scale and you drop the apple, it wouldn't happen the same thing. At that tiny scale, the physics and chemical rules are different, and things are not as we perceive them right here. So, talking about materials, they also change when we observe them at the nanoscale, showing very interesting new properties useful for many new inventions. But how do they manage to control the particles and materials at this minuscule scale?
I will throw a nanoparticle, but I will tell her, nanoparticle, do not go straight, but turn to the left. This is what I'm trying to do. It's super hard, very, very hard, but I am trying.
Different scientists have developed several methods, each one with the idea of fulfilling their objective, each one using different paths and methods.
Los de preparación tienen que estar orientados a los objetivos. Entonces nosotros, aunque hay varios métodos de preparación, durante los últimos años nos hemos especializado en un sistema que se llama plasma, que es simplemente poner en un reactor plasma. ¿Qué es un reactor plasma? Es un reactor donde se ejerce entre dos polos un potencial enorme eléctrico, de tal manera de que se desprenden del positivo, ahí el positivo y el negativo, se desprenden los átomos por la atracción del otro polo, y en el otro lado ponemos el material y los átomos que queremos se penetran en la materia que queremos depositar.
That was an example of how scientists are blending nanoparticles in a material in order to give them the special potential that we can obtain from the particle. The idea is to create a layer on it. Basically, the surface will obtain a new special characteristic.
But one near the other to form a film, a layer, on a surface.
Then they create minuscule layers that gave special characteristics to the surface.
There is nothing, you see? So what I formed is this.
I see.
But here the thickness of what I deposited is 40 nanometers.
It's incredible how workers achieve to make such things with invisible materials. So, what are scientists and engineers using these methods for? What are some active objectives nowadays? What are the principal targets of using nanotechnology? Well, first of all, it's nice that you know that three workers on nanotechnology applied to the design and synthesis of molecular machines won the Chemistry Nobel Prize of 2016, yet showing the impact that nanotechnology is starting to have. These two professors of different countries have won the prize after designing controllable molecules which can be used for several tasks. As an example, different experts are now working on trying to find a way in which a nanorobot could stop the tumor's regeneration of cancerous cells. Just imagine you just drink a pill full of nanometric robots, and in just some seconds, the illness would be healed. On another hand, as I said before, nanotechnology is also having a huge impact in computing and technology. Thanks to the new carbon nanotubes that are being developed, the idea is to build supercomputers with an immense storage capacity, capable of storing more than 50 times what today's computers store. And everything without needing to occupy much space, since these would be stored in tiny microchips. In addition, this would avoid overheating in the equipment and would increase its response.
Furthermore, different scientists also focus on solving different global problems as the contamination in water and surface.
My goal is to prepare bottles deposited with nanoparticles inside for water, that it will be always free of bacteria.
Okay.
Inside. If I make them self-antibacterial, it means this is a revolution. For the poor people, for example, in Colombia, in Tunisia, in Africa, they need something to clean the water.
Yes.
So if they found this, cleaning the water by itself, it means we saved lives. Millions of lives. After deposing on it, after coating inside, I will put water solution with 1 million bacteria and put them in a condition to find the optimal condition that the bottle by itself can kill the bacteria. And this will be an invention.
So, as you see, nanotechnology is giving incredible results nowadays, leaving a great future prospect, making us think, how far can we get?
Pero a veces a mí mismo eso me da como vértigo, ¿no? De saber, de imaginar hasta dónde se puede llegar.
Incredible things are waiting for us, and many new inventions are waiting to be opened. If you think well, inventions that we now consider science fiction can change to reality in just some years. Just imagine that we could take a mountain of garbage and reconstruct its atoms as a totally new thing, like a building or even food. Maybe we can reach this with nanotechnology.
This to show you that nanotechnology is still an open sector, and it's still a very rich media where you can find not easily, but if you think very well and you relate the nanoparticle to the nature, you can create a lot of inventions. A lot of inventions.
Now you know the potential of nanotechnology, and I am sure that if you are interested in the subject and look for a place where to apply it, wonderful things can happen.
Wow, nanotechnology is amazing. We can do everything, Dad.
Yes, really. Now let's go and see your grandfather.
Okay.
I hope everything is better now.
Yes.
Hey, you, come.
Oh my god.
Hey, look. What are you waiting for?